This video, I'm going to give a short overview of, or not so short overview of what we did today. Basically building a new network with the dancer from scratch in Figment, training it, and then seeing how we can generate new images from that. So first, what we want to do is build up the Figmenting. I'm going to skip a few details because we've seen them before, but the idea is that we're going to load a movie here. Normally it's good practice to actually save the Figment file first in the directory where you want this to happen. So I already have one. I'll make a number 2, because then if we load the movie, it's what's called a relative reference to that movie. This is the movie I have. That's the faster movie, let's say. And the idea was to set the speed here to a bit less, 0.5 for example, and then export in a minute in 30 frames. We want the video to be resized. We don't want this one, we don't want this one, we don't want this, so I just select them and then press backspace to delete them. The other side of the video, what we want to do is basically detect the pose. That's this node. So we're connecting that. Here, if we zoom in, we can decide how the pose is going to be drawn. We just want the lines, we don't want the points. And then we take that as the output, turn that here, create a stack, and basically that's our output going to be. Right, cool. That's it for the Figment part. So now we do export. We select the sequence. The node is the out node. That's what we want. We want about 5,000 frames. Frame rate is 30 frames a second. And now we choose a folder where we want to save these things out. The output folder is going to be here. You see I have a couple of ones already. I'm just going to create a new one. Set the image format to JPEG, and then I don't need full quality, so I'm just going to set this to 90 and then press export and let it run. Because I already have the export, I'm not going to keep running this. I'm just going to close this down, but this is so far that's the part we have to do in Figment. All right, going back to our files, let's take a look. So I'm going to go to the Finder, I'm going to go to my project folder, which is here. You'll see in the input folder, sorry, that I have a V007, and these are the files that we actually exported. So as you can see, they all look fine. We just don't have all of them, but I do have them here already. So this is actually the folder that I want to export. So what I'm going to do is turn it into a zip file, delete a bunch of these, and on the Mac it's just right click and compress. Note the name of the directory, because that name will also be in the zip file. So when we unzip, we need that same name. And that's the file we're going to upload. So we're prepared, our files are done, we have our images prepared, and now it's time for the machine learning part. To do that, we're going to go to Paperspace, so paperspace.com, we sign in, and now we can select our workspace that we want to work on. This one, you probably want to just use your private workspace. You can create a project, that's just a name where you put all your stuff in. I have one here. And then in your project, what you're going to do is create a new notebook. Now here are a few important options you have to do. First off, you have to select TensorFlow, otherwise it won't work. Then the machine type, that's up to you. This one is the GPU type. There's a free one available that you can pick. I'm going to pick another one that's a bit faster, but it's up to you really what you want to do. And then here you can select how long it takes before the thing shuts down. In the free version, you only have 6 hours. The longer you do, the longer it can train without you actually having to push a button or do something there. And then importantly, what we have to do here in advanced options is we give the workspace URL to the pix2pix implementation that I wrote. So go to, you can check this as well. Oops, where's my... I have a bunch of these, but this is the one that I'm looking for, github.com/fdb/pix2pix from scratch. So this is the repository that I'm looking for, github.com/fdb pix2pix from scratch. It's also in the video description, you can find it there. The main thing is to try to see if the URL works, and then we're just gonna copy and paste that URL here. I'm quickly going to refresh because I think it might have lost connection here. So TensorFlow, choose the one you want, and then in advanced options, set the URL there. You don't have to change the rest, and then do start notebook. If you feel like you can't type anything here, you probably selected a different image here, like PyTorch, where you can't actually use that. So make sure you use the TensorFlow one. Start notebook. That will take some time, and it will start a machine or provision a machine that we can use. So we'll wait for that to boot up. And then as it's booting up, you'll also see that it says setting up instance here. So you have to wait for that. Another indication that you will have to do is that on the sidebar, you will see a little icon for IPython notebook, which isn't here yet. And that's the one we actually want to use. That's the one we want to click. All right, so it's started and it's now running, and you can see it has this open in Jupyter icon that we can click. So we'll click that, and here we see all the scripts that are running here. Before we actually run the script, the first thing that we need to do is upload our zip file into this system. So the way that we do that is press the upload button here, go to vo04.zip, press open. It says it's quite large, press OK, then press upload again. It's not uploading yet, you have to press the button. Then it says uploading, and now we have to wait a little bit for that to upload. All right, so the file is uploaded. And now we need to unzip it. Unfortunately, we can't really do it here. So if we select this file, you see that's not really an option that we have. So instead, we're going to do that through the terminal. First, we're going to create a folder structure. So in this side, we're going to create a folder, but we'll do that through the terminal as well. That will hold our project. And then inside, we'll create a folder called input that will actually have all the files from that zip file. So let's do that. Let's go to new, go to terminal. And that opens a new screen, as you can see. And a terminal, there's a couple of things that you have to know. First off, the terminal always works in a specific directory. In this case, we're in this /notebooks directory. That's actually the same directory than we are here. If we press ls for list and press enter, you can see that these are the files, the similar files to what we have here. So that's the current directory that we're in. Now, we're going to make a new directory inside of this directory using mkdir, make directory, and then type -p to create subdirectories as well. And we're going to make a project for this called dancer, do /, and then the next one is going to be called input. The names don't actually matter because later on we have to specify these same names there. We can just pick whatever we want. So the first part of this name is actually the name of the project, I would say. And the second one is probably always input, right? Going back here, you can see that this is actually created this dancer folder where inside this input folder is. It's still empty right now, but that's what we have. As I said, we're always working inside of a directory. So what we're going to do now is change into that directory using the cd for change directory command. So we can do cd dancer /input, and that will immediately take us to that dancer input folder. Now, if we do ls, we see that there's nothing there. There are no files there. But we're going to change that. We're going to unzip this file using the unzip command, and then select the vo04, so the zip file that we just created. And if you have a different name, you can just use that name. Note that uppercase and lowercase is really important there. Now, it's not in this folder, as again, we did ls, so we know that it's not in this folder. Instead, it's in 2 folders up. So it's not in the input folder, not in the dancer folder, but in the notebooks folder. To do that, we use ... to mean one directory up. So ... brings us to the dancer folder where it's not. So we also have to do /... again. Now we're in the notebooks folder, /, and now we can use the name of that folder. So vo04.zip. We unzip, and as you can see, it shows all the files that we've unzipped. And of course, there's a bunch of them. Once that's done, we're done here. We don't actually need the terminal anymore, and we can close this window. We can also double check if we go here, dancer, input. It created this macOS folder, which we can ignore, and then there's a vo04 folder. If I click this will take a while because it needs to load these 5,000 files, or a list at least of these files. Note this path. This is really important because this path is actually what we have to type in a moment when we're configuring our pix2pix training script. So we're going back to the home folder, and now it's time to train. So we take the pix2pix_train script, we click it, and now we get into Jupyter Notebook. It's loading the script here, and every one of these entries here is called a cell. We can run all of them to actually start our machine learning. To run a cell, what we do is we press the run key here, or the run button here, or what I'm going to do is press shift and then hold and press the enter key, and that's going to run the cell. So if I run this cell, it's going to install an extra library that I need, which is called matplotlib. for plotting some data and visualizing basically what's going on. So I'm holding Shift, pressing Enter, and that's going to run that cell for me. Same I'm going to do for the next cell. And I can actually run all the cells at the same time together, but I'm going to do this by hand, and that's because in a minute we're encountering a cell that we actually can't skip, because there it's important that we change these directories. So I'm going to hold Shift Enter again, run this cell. That's going to import these libraries, and as you can see, while the cell is running, it gets this little star, and then once it's done, it gives us this number here. Hold Shift Enter here. That's going to print how many GPUs we have available. If this is set to 0, it means you selected a CPU instance and not a GPU instance. You can press Shift Enter on these cells as well. It doesn't really do anything, but goes quicker. And then Shift again, Shift Enter, Shift Enter, Shift Enter. And then here we do have to change this. So we first have to decide what the project directory is. So this is _projects does not exist. That's not actually the name of the project. The name of the project folder is called Dancer. Remember, that's the name we have here. This is our project folder. This is where everything's going to be happening. So we have an input folder now, but we're also going to have an output folder that will have the output of the machine learning. So we're going to leave that here as project folder Dancer. The dataset directory is where the files are stored. And in our case, that's in the input folder. And then so here in this input folder, and then in a folder called V004. So this needs to be changed to V004. The output directory is where the output is going to be. Now, here it's important that we probably want to do a couple of these tests. So I always use output V001, for example, for the first output, V002 for the second experiment, and so forth. The rest we can basically leave as is. We just have to check that our files indeed end in the extension GPJ, which they should if they come from Figment. So we press Shift Enter here. And now we could actually run through all of these cells. Actually, this one is quite interesting. So if we run this, what this is going to do is actually show if it can load one of the files. And that's important. If we made a mistake here, for example, if we miswrite this, and I'm going to press Shift Enter again, and we run this, now you see that we get an error here. This error indicates that it can't actually find any files that's looking for. So make sure that if you have this error, to double check all the entries here. So Dancer, run that again, and then this shows one of the dance images, as you can see here. All right, cool. And now we can Shift Enter through the whole thing. Quickly, there's a bunch of what's called a pipeline that loads in input. This loads the image and splits it into two sides, so the left and the right side, because these are two images merged together. Then it turns these images from 0 to 255 to -1 and 1. It's going to resize and randomly crop the image, and the reason it does that is to make it more robust, so that the dancer doesn't always have to be in the middle. That means that even if the dancer is shifted a little bit, it will still work. So processing image basically does all these steps. Actually, the random jitter here is turned off, so you can decide if you want to turn it on, and I'll turn it on, as you can see here. This means that it's a comment, so it's not executed. It's up to you, and if you forget this step, that's totally fine as well. Now we can run this, and we can see that indeed the image has split, and we have two images here side by side. It can also randomly, so this one also randomly flips the image left to right. So if we run it again, I think we get different variations, maybe. Yeah, so here you can see that the image is flipped. All right, it's creating a data set, which is basically saying, okay, take all the data together, and now that's gonna show us a sample of that data set. There we go. And it's making the generator, the important part. First making a tiny block of the generator that we need, these tiny blocks, and then this is the generator itself. This is what's called a UNet, basically meaning it goes from the big image to smaller and smaller and smaller images, and then from smaller and smaller back to bigger and bigger and bigger again. That's what's doing here. Again, I'm going super fastly over this whole thing. Then we can test the generator, and you will see that it doesn't do anything because it hasn't trained yet. It doesn't know anything about the data. You can see that it sort of gets the lines, but that's just basically almost random noise. The lines are there. We can decide how the generator is scored, so what the loss function is. And then we can build a discriminator. The discriminator is going to find out if the images are actually good enough. So that's what we are running here. That also has a loss function to decide if it's doing a good job. The optimizer is defining how fast the algorithm proceeds or in which direction it proceeds. And This it saves a checkpoint, which is basically a state of the system itself stored on disk. So if everything goes wrong, we can get that checkpoint and start again from there. We don't have to start from scratch. So that's useful. Then I have a couple of functions here. One saves an image, one generates images, and so this saves some images so that we can see these images during training, which is useful. So we can run it here, and we can see the 3 images that it's expecting. So the input image, the real image, and then a predicted image. And as you can see, it's very far off from where it has to go. The summary writing allows us to get a log of what we are doing. And then here's one train step, and then the fit function is actually what runs every time. So we're going to run this. If we have a checkpoint, we can restore it. We don't. And now comes the actual training. So this is the part that takes a long time. Once we're running this, and you see with the star here, it will actually start the training. And as we saw here in the beginning, nothing much happens in the beginning. We just get this little weird look of the whole thing. But as it progresses too, it will gradually improve and get better. So I'll let that run for a few minutes and then come back, and then we can look at the results. So as you can see, it's produced some first results. So this is, we ask it after every 1,000 steps to basically give us some output so we can look at the results here. And you can see it's already doing something that looks like a person. If you're happy with where it is, you can press the stop button and it will stop training immediately. That will work, or you can leave it running. By default, it's set to 400,000 steps. As you can see, 1,000 steps take 91 seconds. So this will take quite a while for it to complete training. But as you said before, you don't have to necessarily wait for the whole process to stop training, because the 4,000 steps here is kind of arbitrary. You can stop whenever you want. Also, the faster your GPU is, the faster this training will go. And you'll see that the free version takes much, much longer for it to generate these 1,000 steps. That's why the for paid version actually makes sense if you're doing bigger projects. Clearly, the model is not amazing yet, but I'm going to stop running here to show the rest of the process. So you probably want to leave this running for a couple of hours or so. So I can press the stop button here. You'll see that it stops the model. From training, it says here keyboard interrupt, which basically means that we stop the training. We don't care about the rest of the input. And this is where we actually going to save the generator and use that in the next step. So we can execute this last script, which is going to take the model directory and create a generator directory inside of that and save the generator there. Then it's going to zip that generator to generator.zip in that same folder. So if we run this cell, it's going to take a while to save, and it's going to zip that file. You'll see that come together here. Right, and now it's zipping that file. And again, once that star has finished here and becomes a number, then you know that this cell has stopped executing and we're done. All right, there we go. Cool. And now we are basically done with this script. If we want to train some more, we probably want to, we can start it again, but for now, we just want to close this file. Leave, yes. And then here for running, we can actually see that we have 2 things running. We have the terminal running. So this is back in the in this view, right? You can see here are my files. Here for the running, what I want to do is shut down this terminal, and also shut down the pix2pix train thing. And the reason why I need to shut that down is because it takes up a lot of memory, and we're going to run a different script, a generate script, that's going to generate new files. And for that, we definitely need more memory than what we have before. Also, we can go take a look at the dancer output folder, V001, and here you see that generator.zip is saved. If we want to download that, for example, to use on our own machine, there's a way to integrate that on our own machine. We can click that and then press download here to download that to the file. As you can see, it's downloading right there. So now going back to the home folder, pix2pix underscore, not train, sorry, pix2pix underscore generate, that's what we want. And also here, the most important part is to set up the directories correctly. So again, same structure, you use Shift Enter to execute all these cells. The project directory was dancer. And here we have to pay attention. So the data set is basically the images that will be used to train. Now we're going to use the same images, but you don't have to. You can actually use different images from dancers, and it would be interesting actually to see what other dancers, if you have other dancers that you didn't show to the original one, how they are going to look. But right now we're going to use the same one. And again, you can look here, we go to dancer, input, V004, that's our input files. We ensure that the output directory is there. Output V001 is the one we want. And then this is where the generator was. This is the directory that we just created. So I'll go back. This is dancer, output V001, and generator. That's the directory we're looking for. This contains the files that actually contain the model. So it's this these smaller files, and then we have these variables files that's really big, that contains all the numbers basically that make up the machine learning algorithm. All right, so we're going to use that directory, and then we're going to say, okay, where does this output go? So it goes in the output directory, V001, but this one we're going to call output sequence or something. Sequence. Again, we're looking for JPEGs, not with an E, so make sure that that's correct as well. We take one from the inputs, and as we can see here, should be able to see, we get one image file. Now, it's only, the generator is only going to be concerned with this image. It's not going to look at this image, so it's only going to look at that image. We can split these up. We can load the generator, so this loads it from the model file. If you get an error here, it means that it can't find it, so make sure that this folder is correct and it can be found. So we loaded it, we created a sample mesh, and now we can plot that, and this is going to show what we're actually feeding the generator. So we just cut off this part because we don't need it. And then we can create an output image that's basically the generator feeding in this sample image that we have here. We can check, and then if we plot it, whoop, what we get here is the output that we had before. Again, we stopped training really early, so we get a really not so smooth image. And then this is basically the main thing that's going to generate this sequence of images. So basically taking all the input images and running them through the system. Now, this is quite big because we have 5,000 images, remember? So I'm not going to do it all. Instead, what I'm going to do here is when I'm loading the image files here, I'm just going to do 1,000 of them. I'm not going to do all of them. So here, after the image F names, I'm going to write, okay, that's fine, but do colon 1,000. And this basically means take this whole list of data, take it from the beginning, so 0, so you can actually write 0 here, and then run until index 1,000, and then we get 1,000 images instead of all the images. And those are going to be output inside of this sequence folder that we generate. So we press Shift Enter, and as you can see, this goes much faster than training, because now we're not actually training every image, we're just running these input images. Remember, that's these ones. We're running these input images through and expecting these output images to come up like this. All right, and seems to be done. So once that's done, we're going to add one command, and I actually make sure that that's inside of the file so you don't have to type it yourself. It's not here right now, but I'm just going to do it here. The idea is to basically zip all these output images. So we're going to do subprocess.run, zip these files with R9. Now I really have to think about what I'm actually trying to do. The output directory is going to be sequence.zip, and the input folder is then sequence, which is the name of the folder that we have here. For that, actually, we're just going to use this output image dir because that's what we have. Will this work? I have no idea. Let's try that out. And then press Shift Enter. Oh, now it says subprocess not defined. So we have to run this cell again. Go back and then run it here. All right, so it's adding all these files. As you can see, there's a bunch of files, and it's adding to that zip file, and then it says completed. So this we haven't done yet, but now I just wrote a piece of custom code. I'll actually include that into pix2pix generate script. And as you can see, we have a sequence file here. We can take that file, select it, download. And now that file is going to contain an actual sequence, an actual dance sequence that we can look at and then turn back into a movie through After Effects or something else. Adobe Premiere or any kind of application that takes in a sequence of images. There, that's done. So we can go look at our sequence. It's in this folder, dancer output VO1 sequence. And here you can look at the sequence that it has generated. And as we can see, it's still super rough. We can actually see the lines a little bit behind the whole thing, which is kind of crazy. But you can see this is definitely already to start a little bit, looking a little bit like a dancer, although it's still super rough. All right, that's it. Hope that was useful. See you next time.